Okay, let's dive into this. Welcome, everyone. As a researcher, I spend a massive chunk of my life poring over field data, trying to make sense of how the natural world operates. And today, we're unpacking one of the most awe-inspiring, frankly mind-boggling biological puzzles on the planet. We are opening up the Naturalist's Field Journal for this explainer to really unlock the mechanics of animal migration. We want to know exactly how, and more importantly, why, millions of creatures cross the entire globe every single year. I always love grounding our field observations with this quote from our source material because, it reminds us that migration isn't some new trendy behavior. Geopaleontology and fossil records prove this is an ancient, deeply ingrained natural phenomenon. It's been happening for hundreds of millions of years. It's this massive survival mechanism, an ancient biological rhythm that stretches way, way back into deep time. Let's move to the agenda and see how this builds our framework for today's comparative study. We'll start with the mystery of the migratory instinct itself, then look at nature's compasses. From there, we'll break down the specific challenges across three biomes: the sky, the land, and the abyss. And finally, we'll tie it all together with their overarching strategies for survival. So let's jump right into Section 1, the mystery of the migratory instinct. Now, out in the field, our first job is to categorize what we're actually seeing. Because animals don't just wander aimlessly, right? These journeys are calculated evolutionary strategies driven by absolute life-or-death survival needs. For instance, we've got trophic migrations, which are all about the relentless hunt for food. Then there's genetic migration, completely driven by the need to reproduce. We also track erratic movements when local resources suddenly dry up, or passive migrations where creatures basically hitch a ride on ocean or wind currents. And whether they're flying continuously along strict routes or taking long discontinuous breaks, every single movement serves a highly precise biological purpose. Which brings us to Section 2, Nature's Compasses. This is where things get really fascinating. Seriously, how do animals orient themselves? It is the ultimate naturalist question. What invisible forces are guiding millions of animals across vast, totally featureless stretches of ocean or sky? Well, researchers have found that young animals embark on their very first journeys possessing an inherited mental map. They haven't been taught the route by their parents, yet they somehow know exactly where to go. They've got distances, directions, and even smells pre-programmed from day one. It's wild. So, the crucial point is how they actually read this internal map. A lot of migrating species use a literal built-in magnetic compass. They have these microscopic fragments of a mineral called magnetite inside their bodies. This lets their nervous systems quite literally feel the angles and the intensity of the Earth's magnetic field lines. And it's not just magnetism. They use the sun, adjusting their flight paths based on its seasonal height, using internal biological clocks, and sometimes even light-sensing antennas to navigate with absolute perfection. Let's shift our observational lens upward for Section 3, Aerial Challenges, the Sky. Up here in the atmosphere, shifting seasonal climates act as a massive trigger for the pituitary and pineal glands, kickstarting some truly epic flights. I mean, just let this number sink in. 70,900 kilometers. That is the undisputed world record for migration, held by the Arctic tern, or the Sterna catalunga. Think about this for a second. We are talking about a bird with an 80-centimeter wingspan, traveling from its breeding grounds at the North Pole all the way down to the South Pole, and then back again. It is an absolute physiological marvel that they can sustain that level of energy output across the entire length of the Earth. But hey, the sky is full of impressive long-haul commuters. You've got the Swainson's hawk, packing vision that's 7 times sharper than ours, cruising from North America down to Argentina at 40 kilometers an hour. That's a 13,000-kilometer trip. The tiny swallow, it pulls off 11,000 kilometers. Actually, scratch that, it's not just birds. Look at the monarch butterfly. This delicate little insect with a 10-centimeter wingspan navigates a 6,500-kilometer path from Canada to Mexico, relying entirely on those sun-sensing antennas we talked about to find its way. Let's bring things back down to Earth. Section 4, Great Movements, the Land. Navigating land is a whole different ballgame. You've got physical barriers, extreme weather, dust, and massive populations moving at once. And this brilliantly illustrates the sheer scale of terrestrial migration. On the macro level, you've got the iconic wildebeest migration in Africa. Imagine a herd swelling to 1.2 million individuals, totally blanketing the Serengeti in search of fresh grass. But then, on the micro level, you have the veined tree frog in Central America. Its migration is just 30 meters, from the high rainforest canopy down to the forest floor pools to breed. The distance is completely different, but the biological drive,
exactly the same.
Land migrations also force some incredibly specific physical adaptations over time. Take the saiga, for instance. It's this spectacular mammal that actually survived the ice ages. To migrate across the freezing, relentlessly dusty steppes of Asia, it evolved this huge, bulbous snout. It looks strange, but it's an anatomical miracle. It acts as an internal heater and a heavy-duty air filter, cleaning and warming that brutal steppe air before it even reaches their lungs. Now, let's dive into our final biome, Section 5, Oceanic Journeys, the Abyss. Down here, animals are navigating a fully three-dimensional, pitch-black aquatic space against extreme cold and crushing pressure. The survival mechanics are just unbelievable. Gray whales actually memorize features of the seafloor, using them like geographic tags. Great white sharks cross entire oceans using these jelly-filled pores called the ampulla of Lorenzini to sense the Earth's magnetic field. And my personal favorite, the tuna. While they're cruising through freezing 2-degree water, their incredibly rich red musculature basically acts as a furnace, keeping their core body temperature at a toasty 11 degrees. And speaking of the abyss, here is another magnificent record breaker, 15,000 kilometers. That is the distance navigated by the female loggerhead turtle, or Tartaruga caretta. She spends 15 whole years maturing out at sea, guided by those magnetic fields and the way light reflects on the water. And after all that time, she manages to navigate all the way across the Atlantic Ocean to lay her eggs on the exact same beach where she was born. Just incredible. Then you have the staggering dedication of the European eel. This is a 7,000-kilometer life cycle that genuinely defies belief. They spawn way out in the West Atlantic. The larvae just drift on ocean currents for 3 years until they reach Europe. Then they swim up rivers and mature in freshwater for about 20 years. Finally, driven by this unstoppable genetic timer, they swim the entire 7,000 kilometers back to the open ocean, reproduce, and die. Talk about an immense biological investment for a single reproductive event. And sometimes, ocean migration spectacularly collides with the land. Just imagine 65 million terrestrial red crabs on Christmas Island. Driven entirely by seasonal rhythms, this massive, crawling red carpet of crabs completely abandons the forest, marching down to the Indian Ocean to spawn. The sheer volume of this biomass moving together is literally one of the most dramatic spectacles on the planet. But you know what? The largest migration on Earth doesn't even happen horizontally. It happens vertically. Every single night, billions of tons of zooplankton execute a 200-meter climb from the dark ocean depths up to the surface just to feed on phytoplankton. And when the sun comes up, they sink right back down into the dark. This daily vertical commute is the foundational base of the entire marine food chain. Without it, the whole ocean ecosystem would just collapse. So we've explored the environments. Now let's tie it all together in Section 6, Strategies for Survival. We've seen the how and the where. Now let's get to the evolutionary why. Now what's really interesting about this slide is seeing our two absolute champions compared side by side. You have the Sternacotalunga conquering over 70,000 kilometers of open sky, and the Tartuga caretta dominating 15,000 kilometers of turbulent ocean. They are operating in entirely different physical realms, but the biological drive inside both of them overcomes these staggering spatial limits for one reason: to guarantee the survival of the next generation. When we look at this matrix as comparative researchers, the evolutionary story becomes crystal clear. The goal of migration is always exactly the same. If there is one core takeaway from our field notes today, it is this: these grueling, dangerous journeys are not random anomalies. They are the engine of species survival. Every migration we've looked at is the result of millions of years of competitive evolution driven by two totally non-negotiable needs: finding enough nourishment to live and securing the optimal habitat to reproduce. But as we close our naturalist journals for today, I want to leave you with a thought. We've seen that these incredible voyagers rely on precise seasonal climates, very specific plant growths, and stable environmental cues to trigger and guide their journeys. So as our planet undergoes rapid climatic shifts, how will these ancient, inherited mental maps adapt to a totally new world? It's a delicate balance, and something every one of us needs to be watching closely. Thank you for diving into this explainer with me, and keep observing.